Hi, my name is Brandon Graisley. I'm a high school computer science teacher, and this is a series about using the libGDX game library for Java, and this is done in Android Studio. We've been making a space shooter game, and this time we're going to add in lasers, and we're going to extend the ship class into two specialty classes, one for the player ship and one for enemy ships. And to do this today, we're going to start by making a new class for laser objects. We have ships, and now let's have lasers. Right click on the package name, new Java class, and we're just going to call it laser. Package private is fine. We don't have any super classes or anything like that. Just press OK. And let's talk about what does a laser object need. It needs to know some characteristics of the, let's call it physical characteristics. In our case, that's going to be the movement speed. It needs to know how fast should it be moving, and this is in world units per second. And if I'm going to show you from the ship class, we had that kind of thing as well here. We also need to know the position and dimensions. Let's see, that's the X position, the Y position, and we'll also need to know the width and the height. So about the X and Y position, unusually here, normally we do the bottom left-hand corner, but in this case I'm going to just use the bottom center of the laser. That way I can use the width to determine the bottom left corner. I'm going to try that. We'll see if it's not necessary to do it exactly like this. You have lots of options. For the graphics, we need a texture region, and we'll just call it texture region. We don't need anything else. I'm just going to move down the movement speed here, because if I put it there, when I generate the constructor, all of these parameters will end up in exactly this order. If I put the movement speed here, I'll generate a constructor in a better order. So generate constructor, choose everything, and you can see the order that's written here. That's the way things end up in the constructor as well, and that's a nice order. X position, Y position, width and height, then the movement speed and the texture region. Okay, we can actually make lasers now, but we can't draw them yet, so let's make a method for that. Taking in the batch, this is just like what we did before with the ship. Let me show you that. Void draw batch batch. The batch.draw all of the ship information and then all the shield information. Let's do the same thing. Batch.draw the texture region, the X position. I'm going to do this like this to start with, but I'm going to make a small change in a moment. Width and height. Now, I mentioned a minute ago that the X position that this is storing is actually the bottom center, and so I want to subtract the width divided by 2. That'll move it to the left enough so that it sort of evenly splits the width on the left and right side of this position. It doesn't have to be exactly like this, but you're going to see in a minute why this is a nice way to do this. Okay, so that's a laser. That's everything we need to know about lasers. Let's go back to our game screen. Where do we make lasers? Well, lasers will happen. Let's scroll way down here into the render method. The render method is about drawing stuff, but it's also, in libGDX, it's also about updating things, moving stuff around on the screen. So somewhere in here, we'll need to create our lasers. Maybe we create them and draw them right there. So we've got a little bit of work to do here. When we create our lasers, we're going to have to store them somewhere because they'll be on the screen for a while. Let's go back up now to the top. Game objects. So far we have a ship, two ships, a player ship and an enemy ship. And we're going to need to keep track of a number of lasers because many of them will be on the screen at the same time. Now there are lots of ways to do that. For example, we could use an array, but I'm going to use a special kind of collection called a linked list. Now a linked list is special because you can very quickly, with low cost, remove items from the beginning or middle of a linked list without all the cost of pushing all of the other objects back into the empty space. With an array, for example, if you remove something from the middle, you kind of have to shuffle all of the later elements back to fill the remaining space. So a linked list takes a generic, it has a generic type in it. So you get to put in what kind of thing you want. And I'm going to put in a laser object. That's going to be the type that the linked list holds. And let's call this laser list. Actually, more than that, I want to keep track of the player lasers and the enemy lasers separately. So player laser list, I'm going to call it. And I need the very same thing for the enemy laser list. Okay, that will keep track of all of my lasers. Let's go and finish that off by actually making the list itself. So we have the game objects, PlayerShip and EnemyShip, and then let's also make the player laser list is a new linked list. And currently in Java, you just put that. You don't need to type in laser here again. It's called the diamond operator. It used to be you would type the word laser there again, but you don't have to do that anymore. Enemy laser list is a new linked list as well. Now, the bit about it being a linked list, that's a choice for efficiency, but really it's just like an array with some extra features attached to it. You can think of it like an array, and it just works better in this case because we'll be removing laser objects from the middle of the list as they impact with the ships, for example. Okay, let's keep going. One of the big changes is that we're going to need the ship to keep track of when it can shoot a laser. So the ship sort of generates laser objects, and then we use them back here in the game screen. So let's go to the ship class. We're going to make some changes here, some additions, and then from there we're going to specialize into the player ship and the enemy ship. So let's first go down to the texture regions. We have a ship texture and a shield texture, and I want the ship to keep track of the laser texture as well. It's going to keep track of that. Actually, I realized just now that these are texture regions. I'm going to rename these. On my keyboard, Shift F6, and I can move down and add the word region there. And I'm going to do that everywhere. You can see that here. It just automatically changes everywhere. This one, Shift F6, add the word region. Yep, do that for the parameter as well. And then this one, region. Okay, now my old constructor does not include that, so I'm going to add in a texture region for the laser texture region. Oops, I should have put my comma over there. And then I need to save that or store it inside of the ship class as well. Okay, so all we've done so far is added in a new field variable to keep track of the laser texture region. It's also there in the constructor parameter list, and it's here. I've stored it right there. The reason that I'm doing this is that I'm imagining in the future I might have different kinds of ships with different kinds of lasers, and I know I will for the enemy and player ships, but perhaps there'll be different kinds of enemy ships with different kinds of lasers. Let's talk about what kind of information we're going to need about the laser for any ship. It's going to need to know the width and the height of the laser so that it can successfully create one. Now you notice I can't use the words width and height, so I'm going to have to call it laser width and laser height. I've already used width and height to represent the ship's width and height. Let's see, what else will I need to know? I'm going to have to know the time between the shots, how quickly should we be shooting. Let's see, I'm going to have another float that is going to be the time since the last shot, or you could call this like laser timer or something like that. That's going to start at 0. It's been no time since the last shot. And let's work with that for now, and we have one more thing. We need to know I'll put it up here. We need to know the laser movement speed. That way we can pass that along. Let me just hop over to the laser for a moment. Position, width and height, and movement speed. The position we'll figure out as we're going. The width and height though, and the speed, we need to know that right away. Okay, so that's enough information to store about the lasers. Let's move down to our constructor again. So far we have a bunch of information about the ship. We have some texture region stuff. We also need to know this information about the laser in the constructor. So laser width, we need another float for the laser height, another float for the laser movement speed. Okay, those are three new things to add to the constructor, and so there are three new things to add down here. This dot laser width equals laser width. Now, as I'm finishing this off, there is another way to do this. Instead of putting everything in the constructor, you could just have like a configuration method that you would call upon the ship after you've created it. What was the last thing I needed to do? Laser movement speed, right? So instead of all this giant constructor, you can just configure the ship and maybe have some default values that are here ahead of time. And then if you don't need to configure it, you don't, but otherwise you would call that configuration method. There's another good reason to do that. We might do it later as well. Essentially, if you want to change these values later, having a method for that might be nice. Okay, the time between the shots and the time since the last shot. So time between shots, we also need that actually. So let's put in another float for that. Time between shots, because we want to, ships will have different times between their shots. So that goes here, time between shots. Whew, okay, that's a lot of information for a ship to be storing. All of that is stuffed into our constructor right now. Once again, that could be done in a separate method. Let's leave it there for now. So now let's write the logic for how to update this information about the laser, but especially this part right here, the time since the last shot. We're going to go down below the constructor, and maybe I'll put it here above the draw method. We're going to write a new method, which is update, and this will update the ship. And in our case right now, all it will do is it will update how long it's been since the last laser was fired. So it's going to need to know how much time has passed. So that is what we call delta time, delta for change in time. And so this is going to be called from the game screen. The game screen will ask the ship to update itself. And one of the things it will do is it will change the time since the last shot. It will increase it by delta time. So we say time since last shot plus delta time. Now another way to write that is just to write plus equals delta time. That will increase the time since the last shot by delta time. And that's all we're going to do for now. Later we'll do some other stuff in there maybe. One more thing we need to do, we need a method which asks the ship, are you able to fire a laser right now? So we're going to have a public Boolean method, can fire laser. It doesn't need any parameters. Essentially, we want to check, has enough time passed? And we'll compare it to the time between shots. So we're going to have a Boolean value. We'll just call it result. And what it will be equal to a comparison. We do a comparison and the result is put into this Boolean. So we'll check the time since last shot, and we'll subtract from that the time between shots. So imagine it's been 5 seconds since the last shot, and there's supposed to be only 4 seconds between shots. That's enough time that has passed. So we want anything that is positive, or let's say greater than or equal to 0, that will be enough. Now the way I would suggest putting this is maybe in brackets here so you can see it. The part in brackets gets evaluated. Is this difference greater than or equal to 0? If it is, result will be true. Otherwise, result will be false. And then we return the result. If you wanted to, you could also just kind of do this all in one line. That's probably what this message is about. If you click on that, it'll fix it for you and make one big calculation and return that final value. Once again, let me just go through this quickly. Checking to see, can I fire the laser? Has enough time passed? Is the amount of time so much that there is sort of some leftover time? It's more than 0, the leftover time. Return that value. Okay, one more thing to do is I want a method that produces an array of lasers. So I'm going to call the method fire lasers. I will only call that method when, after checking, can I fire a laser? And what this will do is reset the counter and produce some laser objects. However, the way that you produce the laser objects kind of depends on whether it's a player ship or an enemy ship. So, because I want to know which kind we have, and there might be other reasons later as well. So I'm not really ready to implement this method, so I'm going to make it an abstract method. An abstract method is not implemented, put a semicolon instead of the braces, and because I have an abstract method, this whole class is now an abstract class. Now, abstract means that some of the class is implemented, some of this code is written, but there's a portion of it that can't be written until the class gets specialized into its subclasses, and that's what we're going to do right now. Okay, let's go back to the game screen class and take a look at what we broke, because we did break some things. All of this is broken. Creating a ship can't happen like this because a ship is abstract. There's not enough information in the ship Java file to make a ship because it's abstract. So we're going to need to make some changes. What's more here is that we also dramatically changed the constructor. So a lot of this is broken now. Don't worry about it yet. Let's go and create our player and enemy ships. New Java class. The player ship class. Now where it says superclass, we want to put ship, and you have to choose this one here. It'll fill in with your package name and then .ship. That can be package private. Let's say OK. Now you'll notice it's underlined in red here. It has to be abstract as well, or it has to implement the abstract method fire lasers. Let's go ahead and choose implement methods, fire lasers, and it'll fill in the sort of beginning of this method for us. There's a little bit more we're going to do in a minute. Actually, maybe we'll start with that. The other error here is the constructor has to be written. So let's create a constructor matching the superclasses, the ship class. And it's going to make this giant list of parameters, the same list that the superclass has. So by default, it just sort of copies everything. And I'll just spread this out so you can see it a little better. Let's see here. Texture regions are next. There's a whole bunch of those. And all this does right now is this calls the superclass constructor method. So it grabs all of this same information and makes a ship using the ship constructor. So it will save all of this information into these same variables. Now these variables are not private. They are called package private. So these are available still in the subclass. If these had been private variables, then PlayerShip would not be able to see them anymore. But because they're not, they are still available. If you want to see that, go over to the Structure tab here and choose the this one right here, this show the inherited stuff, and all of these other values are still available to us in the PlayerShip class. Okay, let's go down to our fire lasers method. Right now it's made a blank one for us, return a new laser with nothing in it. Well, that's not really great. Let's try to do better than that. So the first thing we're going to do is make an array of lasers. A new laser array. I have to say how big to make it, and for my ship, for my player ship, I want to make 2 laser objects at a time, one coming out of each side. So let me load that picture up on the screen so you can see it. Okay, so I went back to my original PNG files to look at the player ship. It looks like this, and I want the laser to be kind of coming from about here and about here on each side. So when I look at this spot, that's the center of where I want the laser to be. You can imagine a laser coming from like there, something like that. So this location in pixels, I'm looking down at the bottom right corner, or sorry, bottom left corner down here. It's about, well, maybe right here. Let's say about 7 pixels from the left. And the whole thing is 112 pixels wide. So 7 out of 112. Let me see what that is as a decimal. Okay, that's about 6% of the way from the left-hand side. So using a decimal to see that. I don't actually care how many pixels it is. I care about the proportion or the percentage from one side. So 0, actually I guess I want about 7 or 8. And if the first one's 0, let me try that again. let's say 8 divided by 112 is about 7% of the way from the left-hand side. So that's fine, about 7% from this side and about 7% from that side. Now vertically, let's see, it counts from the top down inside this paint program. So that's about pixel 38 or so, starting at 0, so about 39 out of 75. So 39 out of 75 is about 52% of the way from the top, or that's 48% of the way from the bottom. Okay, so I can use that to make my calculations inside of the PlayerShip class. I'll check the EnemyShip while I'm at it. The EnemyShip is a little different. I kind of want the lasers coming from about here, which looks like 18 pixels, maybe 19 pixels from the left. So let's say 19 divided by, this one is 103 pixels wide. So 18% of the way from the left-hand side. So 18% for this ship, 7% for the other one. And it's right at the bottom. I can basically start at the very bottom of the image when I make these lasers. Okay, so we'll remember that and we'll write these down when we are coding this. So for the player laser, I need to make 2 of them. I need to make one in the first position, position 0 of the array. I make a new laser. Now a laser needs a whole bunch of information: X position, Y position, width and height, movement speed, and a texture region. Okay, well the width and height we're going to do the X and Y position we'll do in a moment. I'm going to put a couple commas there. The width and height though are already figured out. Laser width, laser height. The movement speed is the laser movement speed, and the texture region is the laser texture region. That part's fine. Now the X and Y position, the X position center needs to be 7% of the way from the left-hand side of the ship. The ship is at X position, and then I want to move in 7% of the width of the ship. So I'll do width, that's the width of the ship, times 7%, or 0.07. Now this is taking a floating point value, so you put the letter F there so that it's a floating point value, not a double value. Now vertically, I want the Y position, that's the bottom of the ship. I need to move up, I think I said about 48%. So let's go up maybe 45%, let's say, times 0.45. Once again, F to turn that into a floating point value. If you don't do that, the error that you'll get is that you have a double when you should have a float, and it's a loss of precision. So turn it into a floating point value. Let me press enter a couple times here so you can see all of the different parameters. So we have the X position, the Y position, the width and height of the laser, the movement speed of the laser, and the laser texture region. All of this will determine the location of the laser, the first one. Let's make another laser, so very same as this one, except this one will go into position 1 of the array. And in this case, we want to have it in a different horizontal location, the X position, but not 7% of the way in. We're going to do 93% of the way, which is 7% from the right. The Y position is the same. So now we've got 2 lasers being produced, and let's return our array of lasers. Now, we probably haven't done this before, but using an array as a return value is nice when you don't know how many lasers you're going to produce. What if this ship gets an upgrade later and can make 4 lasers? Well, then all you have to do is change what happens inside of this method. You don't have to change the calling method in the game screen class. Okay, one more thing before we finish this method off is we need to remember that we have fired the lasers. The one thing that we are keeping track of, let me show you in the ship class, is the time since the last shot. It starts at 0, but it increases as the update method is called. Let's go back to the player ship, and right here we need to reset that value, time since last shot. Notice we can use that because it's not a private variable in the ship class, it's just available to us in the subclass. Time since last shot becomes equal to 0. You can also just reduce it by the time between shots so that it gets rid of only the portion between the shots, and there might be a little bit of decimal stuff left over, but this is a really simple way to do it, and it's really good enough for what we're doing. Okay, we have to do that before the return statement here when the method finishes. Okay, let's go on to the EnemyShip class. Project, right-click, New, Java class. The EnemyShip class is a subclass of the ship class as well. Not much in here. I'm going to go to the PlayerShip class and cut and paste basically everything, and then we'll make some changes to what we see there. So I'll copy that. I'll paste it here, and then we just have to rename some stuff to begin with. The EnemyShip is the name of the constructor. Everything else is actually fine, except I want to change the positioning of the lasers. So let's talk about what we had here. The X position was not 7% of the way in. It was 18% of the way in. And on the other side, we want to be at 18% of the way from that side, so that'll be 82% from the left. The Y position, we want basically at the very bottom. So we're not going to do any of this. Y position talks about the lower left corner of the ship, and we want the Y position to be at the bottom. So that'll be fine for the lasers. Okay, time to return to the game screen class and try to fix our mess here with creating our player ships. What we had done before was made a new ship, and now we're going to make a new player ship. A lot of this is still the same, but a bunch of it has to change. So this is going to stay the same, but after the shield, we have to fill in a few more things. Let's go to the PlayerShip constructor to see what comes after the shield. Laser width, laser height, laser movement speed. So we're just going to write these in for now with some hard-coded values. The laser width I'm going to make 0.4. Oops, sorry, 0.4f. The laser height I'm going to make 4. Is that what was next? Yeah, the height. Then we want the laser speed. That was going to be, I think 45 was a good number. After that, oh, time between shots. Well, how quickly is that guy firing? Let's do 0.5f. That's half of a second between shots. What else do we need? Oh yeah, the texture region at the end. That's the player laser texture region. Okay, so that constructor is completed now. We need to do the same kind of thing for the enemy ship. I'm going to copy and paste this whole row of values and add in the enemy laser texture region at the end. And we have one more thing that I've missed. Oh, right. We need to make this an enemy ship instead of just a ship. Okay, let's change a few values here. The laser width will make a little bit smaller. The laser height will make a little bit bigger, so these ones will look different, maybe a little bit faster, and not as frequent. Okay, so it's a little bit different. We should see some differences in the nature of the player laser and the enemy laser. So now we've created the ships. They know about their own lasers. When the lasers are fired, it will create laser objects and return them back to the game screen. Let's go down to the render method and actually do that part of drawing and creating these lasers. So far all we had done before was draw the enemy and player ships. Let's go down to the laser area and start making these things happen. So for the lasers, we want to create new lasers if necessary. And we also want to remove old lasers, lasers that have flown off the screen, for example. And we want to actually draw the lasers. We're probably going to do that in that order, draw the lasers and then remove old ones. But you'll see how this will happen in a moment. Let's create some new lasers. So the way we do that is we ask the ship, is it time for you to fire yet? And if it is, go ahead and make your laser objects. So let's start with the player lasers first. If the player ship can fire a laser, so that was a Boolean, it was going to be true or false. If it's true, we want to do that. So the laser array lasers we get from the PlayerShip, PlayerShip dot, and we called that method fire lasers. That makes the lasers, let's go back and look at it, makes the laser objects. It also resets the time since the last shot. So that makes our laser objects. Those are in a little wee array here, an array of size 2 in the current example. We need to stick those into the laser list for the player. Now to do that, we're going to need to have a for loop that's going to look at every object inside of this lasers array and place it into the linked list for the player lasers. I'm going to use an enhanced for loop to do that. So this says what type the variable is. The value or the name of the variable is laser, and lasers is the array that I'm going to be iterating through, moving through. And when I do that, I say player laser list dot add, and it's going to be the current laser. So this value laser will become the first laser in the array, the second laser in the array, and so on if there were more than 2. Each one gets added into the player laser list. Okay, there are other ways to do this, but I wanted to show you the enhanced for loop. There is a way to add this sort of in one chunk, but this is good enough for now. Let's do the same thing for the enemy lasers. So instead of PlayerShip, this is going to be EnemyShip. EnemyShip. If the EnemyShip can fire a laser, then we get it to do so. EnemyShip.fire lasers, and we add to the enemy laser list. Okay, so we've created our lasers, and then we're going to draw them. So we have a few things to do when we are drawing these. One, we need to look at each laser individually and draw it in the appropriate place, moving it along as necessary. And we have a choice here. We can either tell the laser to move itself, or the game screen can move the laser manually. And I'm going to choose to have the game screen move the lasers around on its own, because it has a lot of stuff to keep track of in this way anyway, so it's a good spot to make these choices. Now in the last bit here, we used an enhanced for loop to iterate through this lasers array. We're not going to be able to do that now because we need the ability to remove old lasers. And one of the things about an enhanced for loop you need to know is when it's iterating through a collection like this, when it's looking at each laser, you can't change the contents, the number of items in the array. And in our case, it's going to be the array, the linked list that we're working with. So you can't remove lasers while you iterate through. So one option is to make an enhanced for loop for drawing, and then make a non-enhanced for loop for removal, but that's kind of a lot of extra work. What we're going to do instead is combine both of these actions together in an iterator. So this is a new structure for us. An iterator is an object which can go through a collection and can also add and remove stuff as we go along, and it keeps track of things, making sure that there are no mistakes. So let's make a list iterator that will move through our list, and you can see that I can give it a generic type here, or I have to give it a type. You don't have to give it a type, it'll just be object if you don't. But if I tell it that it's going to contain lasers, or it'll be iterating through a list of lasers, then that'll be great. Let's call it iterator, and the first one I'm going to get from the player laser list, and I choose list iterator, the list iterator method. That produces an iterator that I can use. Now we don't use a for loop, we're going to use a while loop. While the iterator dot has next means there is more to look at inside of this list iterator. Well, let's grab the first laser. Iterator dot next produces a laser for us. That's a laser object. Now that has sort of removed it from the iterator. The list is unchanged, but it's kind of used up that spot in the iterator. When I say next again, I'll get the following one. So let's do a couple things now. First, let's draw the laser, laser.draw batch. So that will display it on the screen. The second thing we do is update the location of the laser. Well, my lasers are just moving totally vertically, so I'll change the Y position. How do I do that? I want to move it according to its speed. Now, this is a player laser, so it's moving upwards on the screen. So its Y position will increase, so plus equals. How much does it increase by? Well, its speed is laser.movement speed, but only a certain amount of time has passed. That's in seconds, so if I multiply by the amount of time, delta time, that's speed times time, which gives us the distance change. So we're increasing the distance, or the Y position, by that amount. So that moves it up a little bit on the screen. Now let's remove the old lasers if they're too far off the screen. That is, if the Y position, which is the bottom of the laser, has moved beyond the edge of the screen at the top of the screen. So if laser.Y position is greater than the world height, it's beyond the top of the screen, then we want to remove it. Now there's a command for removing. We ask the iterator to do it. You can't remove it directly from the list, but you just say iterator.remove. That removes the last item, laser, that you retrieved from the iterator. Whew, so that's a lot of stuff. So a list iterator moves through a list, one position at a time. You can retrieve it, do whatever you need to with it, and in this case I'm going to remove it if we don't need it anymore. It draws it, moves it, and then removes it if necessary. Guess what? We're going to do the very same thing for the enemy lasers. So I'm using the same iterator variable, but I'm going to say enemy laser list instead. Everything else is the same except the Y position needs to go downwards with a minus sign. Instead, it's going down the screen towards the player ship. Also, if the laser Y position is greater than world height, that's not good anymore. What we want to know is, has the Y position moved so far down the screen that it's below 0? And not just that, but is the Y position plus the laser height, the top, that'll be the top of the laser, is it below the edge of the screen, that is less than 0? It's been a long time since we've run this program. Let's give it a try. I see no lasers on the screen. We're going to have to do some digging to find out what we've missed. It took me a minute to figure out what I had missed. Let me go back to the ship method and show you what it is that we had missed here. Check it out. You can see it's in gray here. The update method, which changes the time since the last shot, was never called. So it's always been 0 seconds since the last shot. That's no good. That should happen in the game screen method. It needs to happen somewhere up here. We have render, batch begin, we have the background, then the ships are drawn, and so on. So all of this is the drawing stuff, but we also need to update any movement stuff. So I'm actually going to do that right here at the start. We want to do PlayerShip.update with the delta time, and we want to do EnemyShip.update with the delta time as well. Okay, now that it's keeping track of how much time has passed, we should be able to get lasers on the screen. Okay, we've got lasers. That's great. Let's see. The blue ones look pretty great. They're coming out of that location as we expected, and they're moving up here. The red ones, oh, it looks like I've made a boo-boo here. They're coming out of like the middle here. That's because I have the bottom of the laser starting at the bottom of the ship. I need the top of the laser to start at the bottom of the ship. So that's a small change. Let's go fix that. So enemy ship, fire lasers. The position, the Y position, needs to be dropped down by the height of the laser. And here as well. Okay, so let's try that again. That looks better. They're coming out of the right location now. They were starting way up there. Now we still have this problem with the shield, and we've been at this for a bit, but I think it's time for us to try to fix that. I'm going to show you a quick way to do it. It's not necessarily the best way, but it's going to work for us. I need to slide that shield down specifically for the enemy. So let's do that now. You'll remember in the game screen method, if I scroll way up here, we did this, flipping the texture region for the enemy shield. Now it's always being drawn though by the ship class in the draw method here. It always draws it at the X and Y position. The bottom left corner of the shield is the same as the bottom left corner of the ship. And that's not necessarily what we want. I kind of want it to stick out in front of the ship. It worked fine for our blue ship, but the orange one is a little bit different color. Or sorry, it is a different color, but it's also a different shape. I'm going to copy this, and I'm going to go to the enemy ship class, and I'm going to paste it here, and I'm going to put the keyword override in front of it. What this does is it replaces the original draw method for enemy ships only with this new one. Now a nice way to do this would be to reuse as much as of the ship method as possible by calling the Superclasses version of the draw method, but because I have two separate draw things happening, I'm going to just make adjustments by copying and pasting. If I later have to change the ship draw method, I'll also have to change the enemy ship draw method. So all I want to do now is drop the Y position for the shield down a little bit. And I'm going to do it maybe as a percentage of the height of the ship. So let's lower it by the height of the ship, maybe like 20% of the height. Let's try that, 0.2 F. So I'm lowering it by a fraction or a percentage of the height. You don't want to type a number like 5 in here, because if you were to rescale things to draw things at a different, in a different world scale, it wouldn't work so hot. So let's try that now. Okay, cool. My shield is a little bit lower down. 20% looks pretty good, actually. I'm fairly happy with that. I'm happy with where those lasers are. And so some future things we need to work on is checking to see when do the lasers collide with the enemy ship and the player ship. We need to keep track of things like reducing the shields. Also, we haven't been able to move yet. We have to work on setting up some input. So those are some future things that are coming. So stay tuned. And of course, if you have any questions, you know how to find me. Thanks.